Alright, I've opened up Codevision. I'm going to go to File, New, and we'll say Project. And let's go ahead and use the Code Wizard thing. We're going to use an AtTiny chip, so make sure that's selected. And here, we're going to be able to set all of our settings for our chip. So we're using the AtTiny44, a 20 megahertz clock, and the only other thing that we're really going to be worrying about are the ports. So here we've got port A and port B. Now, if we look at our chip, this is the Blink example or Hello Echo example from the Fab Academy. The pins are actually labeled with their official AVR names, not the Arduino names. So if you look for the AtTiny, sometimes you'll come up with this document or this image, which shows different pin numbers. And these are the Arduino pin numbers. And what we're looking for are the actual pin numbers that you might find in the data sheet. So if, for instance, I attached a LED onto PB2, that means port B pin 2. So in here, I would click the port B tab, and I would click here to make bit 2 an output. And this is the initial value. Do I want it to start out being a 0 or a 1? A 1 is a high and a 0 is a low. Just to show you the differences here, I'm going to make this a 1. After this is done, we can just basically go to Program, Generate, Save, and Exit. So in here, let's actually go to Desktop and create a new folder, Flashy. And let's name the project flashy.c. Or that was the C file. Now we can name the project and the Code Wizard file. I just named them all the same thing because they're all going in the same folder. This will automatically generate a large amount of confusing looking code and comments. A lot of this stuff, these are things that we didn't set up, like the clock divider. So if you wanted your 20 megahertz clock divided by 8 for some reason, that's already set up in there. We don't care about port A in our case, in this particular code example, so I'm going to delete all of port A's code. We didn't set up any of the timers, the hardware timers, or anything like that. So I'm just going to straight delete all of that stuff. This leaves us with some pretty simple code. It says include Tiny44, that's the chip that we're looking for, so this is the particular library we need. Int or void main, which is our main code. Now, right up here, this would be like the setup of a regular Arduino code. And then inside this while one, which means run everything in these brackets forever, that's like your loop in Arduino. And the only code that I have left here is the DDRB, which is the direction register for the ports B, for all of the B pins. And that just tells me, is it an input or an output? If it's got a 0, then that pin is an input. If it's got a 1, that pin is an output. So right here, in my example, I said I wanted pin B2 to have an LED on it, so that's an output. So that's what I have here. B2 is an output. The next bit is right here where it actually sets the value of the entire port, port B. And it sets these individually. So pin B3 is a 0, pin B2 is a 1, so that's that initial value I set. B1 is a 0 and B0 is a 0. So that's just, if I just ran this code by itself, it should turn on the LED on port B, and that's it. It ends. There's nothing else is going to happen. It's going to actually just go in this while loop forever, and nothing's going to change. That LED is going to stay lit. But let's go ahead and make this so that it will flash. So what we're going to first do is copy our include file and paste it below, and we're going to change the name here to delay. And that allows us to use the delay function. Now, you might have seen just the pop-up there. It kind of helps us figure out whether or not our code will be valid. If it doesn't pop up anything, then maybe that's not right. So the first thing I want to do in this while loop, since I initially turned that LED on, let's delay for, select delay milliseconds, and let's delay for half a second. The next thing I want to do is I want to set the value of port B equal to some value that will turn off that LED. In our case, I'm just going to put 0x00. What this means is this is a hexadecimal number, which is a shorthand for binary zeros and ones, and we're just setting everything on that port to 0. So that'll turn off all output pins. That will write a low to them in Arduino code. Then we're going to delay for another 500 milliseconds just so we can see that it turned it off. And let's go ahead and set it so it will turn the pins on. So this is 0xFF, so that is basically I am writing ones to it. Again, this is hexadecimal, and if you use like the Windows calculator or Google and you put in 0x means hexadecimal, FF is the number, so that's actually 255, which in binary code is 11111111, and that will actually turn the LED on. So it turns all of the output pins high. And so that's the end of the code. We're just going to flash that LED. So the next step is going to be we need to save. So save the file. Come up here, and you can actually do compile first, and that'll kind of give you a little heads up. Hey, yeah, it compiled. But let's in fact just go to build. So compile just checks to see if it would work. Build will actually write your hex file, and that's what we need. And you know, just to be safe, let's try build all. So, and you notice we don't have but maybe like 50 lines of code, but it says it compiled 649 lines of code. That's because it compiled everything that was in those two libraries as well. So don't worry about that. All you really want to worry about is no errors and no warnings. And you can also see your errors and warnings in this little console window down here. Once we've got that built, we can find our example. So you can ignore my crazy amount of icons on my desktop. So if we open up that flashy folder and we go into debug and exe, we see our hex file. We can take this hex file and upload it to our AtTiny chip using AVRDude. So AVRDude is a command line software, so you can look in the make file that is given here. If you we're looking at this hello world thing. If you look at the make file, just save this as capital M make file with no extension. That should allow it to work. You can open it up, and we're going to be using the USB Tiny. So if you wanted, actually, you don't even need the make file. You could just go here, copy this piece of code right here, and paste that into the terminal, and change this $project.c.hex to flashy.hex. Or in fact, what you could do is, to make it a little bit easier, this is the only .hex in this folder. So when you run the code in your terminal, even though this isn't really going to be the real terminal, but when you run that code in the terminal, all you really need to do is replace the $project.c with just a asterisk, and it will download anything that's .hex to the chip, and then hit enter and it should work. Now I don't have anything connected to mine, and I didn't open up the right terminal in the right place or anything, but that's the gist.